Hello everyone, welcome back. We're gonna start with this basic foundation we did it. Then we can write columns. Those are the columns we did them, but I can say this is columns between the short columns. Short columns. I can just name them in a way that for myself to remember them later. I can say this is ground floor columns. Ground floor columns. Because naming them, it's good to remember later for checking. Now, when we start with the ground floor columns, some information we have to know. First, the dimension of the column are the same dimension that provided here. So we have the same type of columns. For example, 25 by 60 columns. Those are the name of the columns. Or you can use their name, S1, S4, S2, like this. Now, let me start with one of them. Let me start with S. For example, this is, let's say S4. I'm writing S4 here. Writing S4. Now, when we're writing S4, I'll write 1. We may have different S4s. Similar S4s, 25 by 60, we have it here, 25 by 60, 25 by 60 years. But why will I write here 1? Because there's something I want to explain for you. The height of the column, where do we get it? So I know that this is, let's say, 0.6 by 0.5, 25, we know this one, 0.25. How about the height of this column? Where do we get it? S4. Now, in order to get the height of the columns, where do we have to go? First, we'll go to the sections. One of the section to see the height of the story. When we say the height of the column, we normally cast column from the top of the slab till the bottom of the beam. This is what do we mean by the height of the column. So we cast column on the top of the slab till the bottom of the beam. So it means that in order to calculate the height of the column, what do I need? I need the story height. I need the story height, and I need the beam height. Why? Because if I have the story height, for example, if this is, let's say, 4 meter, whatever, we're going to come back to it. And if this is 0.5, this is an example, it's not the real one. So 4 minus 0.5, I get the height of the column. The height of the column will be 3.5 meter. 3.5 meter. So we need one, we need the story height. The story height is from where? From the top of the first ground slab to the top of the first story slab, or you can say ground floor slab. I mean, from here till here. This is slab on the grade. This is the first slab we have it, or you can go first story slab, and the other one we call roof slab. The naming they change according to the countries. Some they call this one first story, some they call this one ground story. So I'm not going to go into that one. The idea is what from where to where is important, not the names. So in order to get this one, we come to the section. First thing we'll look what? We'll look to the story height. Look, we have two types of story height. One which is the ceiling, I mean the inside, which is 285. Then the other one is what? From here, from top. Why do I need this one? The question, I'll answer this question. Why do I need from here till the top? Which is going to be what? 285 plus 15. Plus 15, which is going to be, let's say, 3 meter. 3 meter, we have it here. Now, why do I need this one? Why do I need this one? When we calculating, when we want to take out the beam height on the plans, this height is given to us. The height, the total height of the beam is given to us. So for me, it's easier to take it from the top in order to take the height of the beam from the 3 meter and get the height of the column. Now, the thickness of the slab might change. From here is 15. Sometimes might change. So that's why I'm not taking it from the bottom. I'll take it from the top. Because if the thickness is 12, then one side our calculation will be wrong. Or let's say this side of the slab is 12. So if I take from the bottom, I have to calculate how much is this extra here. For example, this extra from this side is different, because if this side 15, the other side is 12, then the beam has from this side is different than this side. And if I use both sides, I'm supposed to get the same height of the column, because the column basically it's at the bottom of the beam. So for me, which one is easier? The top part is easier. The top part is easier. That's why we go to the top and we take out the height of the beam from it. Well, now I know the height of the first ground floor, it's 3 meters. The same thing for I can check it from here if I want to see how much is this one here. This is given 285. Let's say the same thing, 3 meters will be the second story as well, or the first story, whatever you call it. If you call this one ground floor, this is first floor, or first story, second story, whatever you call them. Both of them 3 meters. From where? From the top of the slab to the top of the slab. Now, when the dimension of the beam given to us, let's say this is the beam, we have it here, the dimension of this beam will given in this manner. Let's say it's written 25 by 60. So this 60, it's the total height of it. This 60, total height of it. That's the other reason that we want to calculate from here till the top, as we said that if I know this one, and if I want to take out this one, I can get the column's height easily. So we have 3 meters for the 2 stories, and if you know the thickness, the depth of the beam, I can get the height of the column. This is one information, or some information you need to know when you calculate the height of the column. Other information that we need to know is on one column there are more than one beam. On one column there are more than one beam. You may have 2, 3 beams that coming over one column. Now, there's another information that we need to know for this type when we have more than one beam. Most of the time there is more than one beam on the column. Now, I want to draw something here to let you know that what we have to know, this is a column, I have it here. We said column will finish at the bottom of the beam. Now, what if we have different size of beams? Not always you have the same beams. Sometimes you have different size of the beam. Let's say there is a beam here. By the way, the beams are coming till the end, but I'm just not drawing them till the end so that to explain what is it. The other beam that we have it is shorter. So when we do the column is supposed to stop at the bottom of the beam, yes? So which beam? The longer beam. For example, this beam, it's deeper. For example, if this is 70, this is 50. So when we're calculating the height of the column, we calculated till here, the 70, not here. At the end, sure, those beams were gonna come. I mean, this is gonna continue when we're doing the beams. Sure, we will fill this gap. It will be filled because the beam when we're calculating the beam, I will tell you that we consider this to be the length of the beam. From here, we'll consider like this. The beam will be considered like this, the length. But for the height of the column, remember when you have multi beams on the column, you'll check which one is the height, has the deepest. Then you're going to use that one in order to calculate the height of the column. So let's do some examples to see. That's why I put it S4. I didn't put all of the 25 by 60s. Maybe their height will not be the same because it depends on the beams that come in. If they are the same, you can just put them S4, S5, whatever the names. You put, for example, how many of them and if they have the same height. Because we know that their dimensions are the same, but the height might be different due to the beams on the columns. Well, let's see S4. This is S4. This is S4, you can see it here, and we have 2 beams coming over it. The beam's name, this is 103, and beam 111 or 111. The dimension of them 25 by 60, which is the dimension of the beam, and the dimension here 25 by 60. So you realize that the depth of the two beams are 60. So it means that I don't have any problem when we're calculating the height of this column. I can use 60. Well, you can check somewhere else to see. I have one here which is different. For example, this one here. Let's say checking S8. S8 has 3 beams. S8, this column, there are 3 beams coming. One of them, it's 217, which is 25 by 60, 206, 30 by 70, so I have 70 here. On the other side, 25, 60. So which one will decide the height of the column? The highest or the deepest beam, which is the 70 here. So we're gonna, when we're calculating for S6, this is for the second story, by the way, for the second story, we're gonna use 70 in order to calculate the height of this column. Let's check S8 in the first story. S8 in the first story, it's here. S8 in the first story, there is 2 beam coming, 60 from that side, 60 from that side. So for S8 in the first story, we don't have 3 beams, we only have 2 beams, so 60 will be used to calculate the height of this column. You remember why we need this 60? Because we said that in the section we showed to you that we have the height of the story minus the thickness or the height of the beam going to give us the height of the column. So here we have 3 meter minus 60, which is going to be 240. We're going to write 2.4 the height of this column. Now you can check the other columns that they have 25 by 60. Their dimension 20. Which one is it? We already know them from here. Even from here you can see them. For example, 60-25. This is also 60-25, S2. S3, 60-25, 60 is. If I check S2, S3, would their height will be the same? I can see from here. S2, there are 3 beam. 25-60, 25-60, 25-60. So the height of S2 is the same height as S4. For S3, 60-60. So the same thing. Why? Because they are for the same story and their beams are the same, so their height will be the same. So I can write here, for example, S4, I can write it like this. S2, S3, S4, and add all of them at the end. For example, how many of them I have it, I can change it to 3 rather than to write them one by one. But remember, if their height is the same. How do I know their height? By checking the beams on the columns, the same dimension. If the beam's dimension, for example, 60, 60, 60, so the biggest is 60. For this one, it's the same thing, 60, then we know that their height will be the same. And the rest you can see, for example, S6, 60, 60, 60. So the same thing we have it here. For S8, the same thing. S10, for example, I have 25, 60 from that side, 25 from 60 that side, so the height of it will be the same. This one, S9, so I can write all of them here, most probably all of them the same. How can I do this one faster? I can check the beam in the first floor. Roughly check all the beams. 20, 60, 60, 60, 60, all the beams except this one here, it's 40 here. But again, the highest is 60, I have it here. So still I'm on the safe side because I'm looking for the deepest beam. This is 40, I have 60 here, no problem, 60. I'm looking if I have something bigger than 60. Because if there are beams bigger than 60, then the height of the columns will be shorter. So for the first floor, I can see all of the beams, the highest depth of the beams, we have it is 60. So all the columns will have the same height. All the columns, they have the same height. But for the second story columns, we saw 70 there, we have some 70s, so in that case we have to be careful because we have different size of the beams. Some of them are 70, so the 70 may govern the height of the columns. So in that case you can simply bring the things that you wrote it here, the 8 of them, 2 of this one, except the round columns. The same thing, for the round columns, we'll check here to see the same thing. Well, the beams are connecting in the same way, so we can calculate them the same as here. Or if you want to calculate the columns, let's say, look at here, the columns here, the slab, since it's coming there, you can calculate it at one separately, because the slab most probably it's coming here according to the plan, but here it's not clear. It's coming inside it. So we divide the same thing. This is as two columns, one here, one at the top. But if it is not, if the slab is not coming, you can just calculate this round as one. For example, most probably it's calculated till here, or if this part is the column, it will calculate as ones. We can calculate it. It depends on the plan we have it here. But according to the civil engineering drawings, I mean, we have a slab here, so we can just simply put them at the same manner, the same height, then for the second story, the same manner. So this is how we're calculating the reinforced concrete for columns. What we said, the dimension, we're taking it, and in order to calculate the height, what do we need to know? We need to know from the section that we're calculating the height of the columns from where? From the top of the slab to the bottom of the beam. Even for the second story is the same manner, from the top of the slab to the bottom of the beam. Since we know this one, we said what do we need in order to calculate this height easier? We said we need a dimension which is from the top of the slab to the top of the slab. From top slab to top slab, it's easier for our calculation, because when the beams given to us, the dimension of the beams, we can just take the total height of the beam. Out of this, we can get the height of the column. We said another information required, we have to know how many beams are coming over the column, and we have to take the deepest beam in order to calculate the height of the column. Thanks for watching.